Good afternoon to one and all. This is Gopi Krishna, Assistant Professor, Department of Computer Science and Engineering from Chevrolet Engineering College. Subject is compiler design. In previous class, we are discussing about LALR parsing technique with examples. So now we are going to discuss about ACK parser generator. So in previous unit, in unit 2, we are using Lex lexical analyzer generator. So in the same way, we are using ACK parser generator. So coming to ACK parser generator. So this is one. So parser generator. So how to parse the generator? So for example, for one input is taken from the source program and we are converting that source program into stream of tokens by using the Lex tool, right? సో లెక్సికల్ అనలైజర్ జనరేటర్ ఏం చేస్తుంది సో సోర్స్ ప్రోగ్రామ్ ఇన్పుట్ గా తీసుకొని వీ హ్యావ్ టు generate with that source program to the stream of tokens. Okay, that is the Lex tool. Okay, we are taking the input as a source program and we are converting that source program into stream of tokens by using the Lex tool. Okay, so in the same way we are using YaCC tool also. So what is parser generator? A program which takes a specification of the syntax of a language in some from as input. సో ఒక ఇన్పుట్ అనేది తీసుకొని సో అది ఎలా ఉంటుందంటే ఏ లాంగ్వేజ్ లో తీసుకుంటున్నామో ఆ లాంగ్వేజ్ లో ఉన్న సింటాక్స్ ని యూస్ చేసుకొని ఇన్పుట్ తీసుకుంటున్నాము అండ్ ప్రొడ్యూసెస్ యాజ్ ఇట్స్ అవుట్పుట్. ఓకే, సో అవుట్పుట్ అనేది జనరేట్ చేస్తున్నాము. సో ఇక్కడ అవుట్పుట్ ఎలా జనరేట్ అవుతుంది? ఈజ్ ఏ పార్స్ ప్రొసీజర్ ఫర్ దట్ లాంగ్వేజ్ ఇస్ కాల్ ద పార్సర్ జనరేటర్. సో మనం పార్సర్ జనరేటర్ గురించి మాట్లాడుకుంటున్నాం కాబట్టి so we are taking the language as a parser specification of syntaxes and it is taking the input from the stream of tokens and we are converting that stream of tokens into syntax tree or a parse tree by using parser generator. So we are using this parser generator. We are using one tool that is YaCC tool or YaCC parser generator. So what is YaCC means? That is yet another compiler. So it is a program or a tool. Okay, so YaCC tool or a program. So what is YaCC means? Yet another compiler is used as a parser generator. So how to use this YaCC tool or YaCC parser generator? For example, so we are using ACT tool or ACT program. So ACT can take the input from the Lex tool. So what is Lex tool? So lexical analyzer ఏం చేస్తుంది? So we are using Lex tool or a program. So we are converting the source program into a stream of tokens by using the Lex tool. So that is the input is source program and the output is stream of tokens. So here the Lex tool is generating the output. That output is taken by the ACT program, ACT tool or a ACT program by using the input. ఓకే, సో ఎక్కడైతే లెక్స్ ప్రోగ్రామ్ అనేది అవుట్పుట్ వస్తుందో ఆ అవుట్పుట్ ని ఇక్కడ యాక్ట్ టూల్ అనేది ఏం చేస్తుంది? ఇట్ ఈస్ టేకెన్ యాజ్ ద ఇన్పుట్. సో వాట్ ఈస్ ద అవుట్పుట్ ఆఫ్ లెక్స్ టూల్? సో ద స్ట్రీమ్ ఆఫ్ టోకెన్స్ యాజ్ ద output for the Lex tool and it is taken as the input of this ACT program. Okay, the stream of tokens as the input and it is converting into a source a syntax tree or a parse tree. Syntax tree or a parse tree. So here it is. So ACT can take the input from the Lex tool, that is the stream of tokens, and get the output is syntax tree or a parse tree, right? So syntax tree or a parse tree, whereas the lexical analyzer we will use the Lex tool. This Lex tool is used to take the input from the source program and get the output is stream of tokens. So stream of tokens and the source program తీసుకొని that source program is converted into a stream of tokens by using the Lex tool. So thus that output, that is the stream of token, is taken as the input in this ACT program. So input and we are converting that stream of tokens into a syntax tree or a parse tree by using the Lex tool or YaCC tool or YaCC parser generator. So this is the parser generator we are using YaCC tool or YaCC program. So YaCC is abbreviated as yet another compiler. Okay, so in this so we are having the one figure. We have to convert the ACK file to the given output. So we are converting a ACK file, that is stream of tokens is the input, and it is converted into uh, syntax tree or a parse tree. So this is the figure we are using to conversion. So here ACK specification. ACK specification means we are using the file. One program is taken, so that used with the dot extension with y. So by using in a lexical analyzer. So lexical analyzer ఎలా ఉంటుంది lex. So that is we are using one file name dot L. So we are using the extension is dot L. So in this ACK compiler, ACK file, we are using dot Y is the extension for the ACK program. Okay. So here ACK specification. So we can specify the file name dot Y. So dot Y is the extension for this ACK program, and we are using ACK compiler. We are using ACK compiler. So it is generating. So we are taking the input of ACK program, and ACK compiler can convert this ACK compiler convert this file with y dot tab dot p. So what is the dot p extension? So it is a C file. Okay. So that C file is taken as the input. So y dot tab dot p. So we are giving to the C compiler. So C compiler can convert this program into a dot out. So we can generate the output by using. So that is the input. So we are converting a dot out with output. Okay. So that means we are taking the ACK specification. So this is the file name. We are using the stream of tokens. So stream of tokens taken as the input, and we are converting the output is parse tree or syntax tree. So this is the ACK specification diagram or a figure. Okay, so what about this one? So it is a lexical analyzer generator. So in this lexical analyzer generator, we are using lex specification. So that is file name dot l. So already we have already all of you know. So what is the dot extension for the lex program dot l. So we are using file name dot l, and by using lex compiler, then we are converting this file name dot l into lex dot yy dot c. So all of you know lex dot yy dot c. So what is dot c extension? So it is a C program. So lex dot yy dot c, by using C compiler, we can produce the a dot out, and we are taking this one as the input. So this is the a dot out is the source program. So we are using one source program that is given to the particular one, and it is converted that program into stream of tokens. So we are taking the input string from a source program, and we are converting this one into stream of tokens. Here is also same. So we are using compiler C compiler. So here C stream of tokens can be generated with the syntax tree or a parse tree by using this diagram. Okay, so this is the difference between lex analyzer generator and ACK program generator. So here we are using dot l in lex compiler, and dot y we are using ACK compiler. Okay, so we can convert this one and to. So here we are taking the source program as the input and converting the source program into, by using lex tool, we can convert this into stream of tokens. So the output of lex compiler, it is taken as the input of ACK compiler, ACK program, ACK tool, and that stream of tokens can be converted by using the ACK tool. We can convert this into a syntax tree or a parse tree. Okay, so this is the diagram to specify the like ACK generator. ACK generator. Okay, then next one. So here the structure of ACK program. What is the structure of lex program? Anyone? What is the structure of lex program? Anyone? Boys or girls? Anyone? తెలీదా? So the structure of Lex program is same as the structure of ACT program. So in this Lex program, we are using to specify three three functions, three specifications. So first one is the declaration section, and second one is the translation rules or rule section, and third one is the auxiliary procedure section. So these are the three types, that is declaration section and translation rule section, and we are using supporting C routines or auxiliary routines. So these are the three functions, three types. So we are specifying the structure of ACT program. So the structure of ACT program defines declaration section and translation rule section, and we are using auxiliary functions. Okay, auxiliary procedure section or auxiliary function section. Okay, so these three are used to in structure of ACT program. In the same way, we are using the structure of Lex program also. We have three three specifications. So first one is the declaration section and translation rule section, and the third one is the auxiliary procedure section. So these are the three types in a structure of Lex program as well as structure of ACT program. So what is the declaration section in ACT program? So in declaration section, we have to declare the C variables or a C constants, or is there any header files that are present in our program. We have to include the declaration section only. So in declaration section, what we are using? So we are using a C variables or a constants or a header files we are used to specify. So in the declaration section, we need to specify the syntax for the declaration section is so by using this percentage open curly brace and percentage closed curly brace is used to the declaration section. So this is the syntax. So we need to specify the declaration section. So we are using the syntax is percentage open curly brace, and it is also end with percentage closed curly brace. So in between the in between in between these two, we can declare the declaration section. So we are declaring C variables, constant, and header file. So here we are using int x comma y. We can specify. So we need to one specification of one constant. So we are using the name constant const. It is a name, and int a equals to 20. So whereas a present, the value of a is always 20, and we need to specify one header files hash include stdio.h, hash include conio.h. So this type of header files we need to declare in the declaration section. So we can declare declaration section, we need to use the syntax is percentage open curly brace and percentage closed curly brace. In between these, we are specifying the declaration of C variables and C constants and header files. Is there any requirement? So we can declare those into the in between the percentage open curly brace and percentage closed curly brace. In between those, we need to declare the those variables are constants or header files. So this is the declaration section. So what is the next one? Translation rules. So we need to specify the translation rules. Then we are specifying the percentage and in between percentage. So we need to specify the translation rules. So this percentage specify the starting of translation rules, and this percentage specifies ending of translation rules. So we are one example. So percentage and percentage we can know any programmer or any user, we need to identify that is the translation rule section. Okay, so that is the syntax for the translation rule. So percentage and percentage we are using the translation rules. So we need to specify the translation rules. So first percentage specify the starting of the translation rules, and second percentage represent the ending of the translation rules. Okay, so here translation rules. So here translation rules. So we are used to specify so percentage and percentage. For example, so in percentage. So what is the purpose of ACT program? So what is the main purpose of ACT program? So it is taken as the stream of tokens as the input, and we need to convert the stream of tokens into a syntax tree or a parse tree. So syntax tree or a parse tree. So we have one grammar. Okay. So what one grammar that is specified in so in this way. So here head head is represent the left side non-terminal attribute value. So here head is representing left side non-terminal attribute value, and here is the production value and body 1 or body 2. So body 1 represents, so here for example the production is like this. So A produces AB or BA. So here A is the head value and production. So AB is the body 1 and BA is the body 2. Okay. So this is the production. For example, so is there any production with E produces E plus T? Okay, so that is one production. Here we are representing head produces, so head produces body 1. So total body 1 is represented in 1. So is there any another alternative? Then we are using the R value. Okay, so R value. Okay, so this is the representation. Head produces body 1 or body 2. Okay, so it is the general syntax. So in translation rule section of percentage. So this production is written as, so this is the syntax for the translation rules. So head colon. So head means the left side non-terminal attribute value and colon body 1. So here body 1 is AB. Okay, so AB, and in between curly brace, open curly brace and closed curly brace, we are using the semantic action. Semantic action means so what is the body 1 represents. So for example, the production is in the form of here E produces E plus T. So this is the representation of addition operation. So E plus T. So then semantic action is representation of addition. Okay, so that is the, we can say specify the semantic action. Okay, so head colon body 1. So body 1 semantic action, and here another value body 2. So var body 2 with semantic action. So this is the specification of translation rules. For example, in this translation rules, so we are having one statements. For example, one expression is available. So E produces E plus T. Then we are representing E. So in translation rules, so we are using dollar and dollar I. Okay. So dollar represents the left side non-terminal attribute value, and dollar I is represent the ith symbol of the body. So for example, here body 1 ఉంది అనుకోండి. సో అందులో బాడీ 1లో ఫర్ ఎగ్జాంపుల్ ఏ ఆర్ బి ఉంది. సో ఏ ప్రొడ్యూసెస్ ఏ, బి ఉంది కదా. సో ఏ ఈజ్ రిప్రజెంటింగ్ డాలర్. Okay, and produces small a is represent $1, and here small b is representing $2 value. So that means $I is the ith symbol of the body. So body లో ఉన్న ith symbol. So ఇది first one, ఇది second one. So అలాగే ఇది first one, ఇది second one. So A produces AB, A produces BA తీసుకుంటాం. So we are representing this one translation rules we are using. For example, let us consider this example. A produces B plus C. So A produces B plus C means A is the left side non-terminal attribute value. Okay, left side non-terminal attribute value. So this left side non-terminal we are representing dollar produces. B is the B plus C is the production value. Okay, so here B is the first uh, first symbol of body, okay, and plus is the second symbol of the body, and C is the third symbol of the body, right? So this is first symbol, this is second symbol, this is third symbol. So we can specify $1, $2, $3. Okay, so this is the specification of dollar and dollar I. We are using the translation rules. So here is the translation rules. So this is the production. Then we are writing head colon body one. Here we are using in between the curly brace. We are using semantic action, or body two we are using semantic action. So this is about the translation rules. Okay. So first one, what is the declaration section? So we need to declare the C variables or C constants or any header files we have to specify in that declaration. We are using declaration section. So what is the syntax for the declaration section? We are using percentage open curly brace and percentage closed curly brace. We are using in between these two. We need to specify the declaration section. So what about our translation rules? We are using the percentage is the starting of the auxiliary section, and dollar percentage is the ending of the uh, translation rule section. Okay, so here so is there any productions with that so that is we are representing head is production with body 1 or body 2 or body 3 in the same way. So that can be represented head is colon body 1 semantic action or body to semantic action. Okay, so that is the syntax for the translation rules. So in this translation rules, we are using two syntaxes, that is the dollar. So that is the representation of left side non-terminal attribute value, and dollar I is the ith symbol of the body is we are specifying the dollar C. Okay, so this is the example for we are specifying the dollar and dollar I. Okay, so this is the translation rules. What about auxiliary functions? So we are use any C functions. So we need to specify the auxiliary function section. Okay, so we are taking one example. We need to understand the what is declaration, what is translation rules, and what is the auxiliary function. So here we are using the simple desk calculator. So this is the example to construct ACK tool. Okay, so here the file name is translate.y. So that is what is the dot extension for the ACK program? So that is dot y. So this is the ACK program. So why? Because so it is the dot y extension. Okay, that is ACK program. So we need to specify percentage open curly brace and percentage closed. So here closed is missing. So percentage closed. Here we are writing. So here percentage open curly brace, and here we are using percentage closed brace. So missing the one. So this is the percentage open brace and percentage closed brace. In between we need to specify the C variables or C constants or any header files. So we are using in this declaration section hash include ctype.h. So what is ctype.h means conversion type header file we are including in a declaration section. Why we are using this one? So in this one, each digit is a one function we are using. Okay, built-in function. So in this one we need to having the C type conversion. So but that is the header file. So we are using to declare this header file onto the declaration section. So here the percentage tokens digit. So it is not under declaration section and not under translation rule section. So it is a separate specification of tokens. So hash percentage space tokens using digit. Okay, so this is not under declaration, this is not under translation rule section. So this is a separate one. Okay, so why? Because we are need to specify the tokens, right? So this is the declaration section. So here we are using percentage closed curly brace we need to place here. Okay, then the percentage. So what is the percentage? Percentage means so it is the starting of the translation rule section. Okay, so in the starting of the translation rule section, percentage, we need to see. So this is a given example. So example is E is production with E plus T or T, and T is production with T star F or F, and F is production with open curly brace E, closed curly brace or ID. So here E represents the expression and T is representing as a term and F is represented as a factor and this ID is represented as a digit value. Okay, so expression, term, factor. Okay, so this is represent expression and this T is represented as term and this F is factor. Okay, so here line, for example, in line 1, so line 1, line number means, so this is the first expression. So E is the head value. So EXPR slash n, so that means printf percentage d slash n colon $1. So here we are representing the $1 is the production. So $1 means you need to specify the value e. Okay, and what is the expr? So expression, so here expression call చేస్తున్నారు. So expression means head. So head colon and we are specifying the some dollar, we are specifying expr and plus is the operator symbol and what is example e produces e plus t. So we are specifying e as a expr produces and a expr colon, here expr and plus is the operator and t is the term. So we are specifying expr colon expr plus term. So what is the semantic declaration? So here is the semantic declaration. So in this one, so head colon body 1 and semantic action, sorry, not a declaration, semantic action. So we are performing the action is so expr colon expr plus term. So we are using the semantic action. So expr is the left side non-terminal attribute value. Then we are specifying the dollar equal to. So production is nothing but so we are using equal symbol and this e is represented in the left right hand side. So this is the body, e plus t is the body. Then we are specifying e is the $I. So I means first ith symbol of body. So here $1 and plus, so plus is the $2 value and we are using uh, and we are using and we are using $3 as the term. So we are specifying like this. So this is the semantic action. So we need to close the curly brace and so E produces RT. So E produces means EXPR colon R T. So T is the term. So we are specifying EXPR plus term and this is the semantic action. Then we need ORR term. Okay. Then next term. So next production term is colon. Term is colon and here term star F. Term star F means term star is the multiplication operation and F is the factor. So we are specifying term star factor. So what is the semantic action? So T is the left side non-terminal attribute value. Then we are specifying dollar equal and here $1. So we are missing one. T is the term. So $1 star F. So star is $2 value and $3 is the F. So we are specifying $1 star $3 and next here also and one more production. So that is R factor. So F is means factor. Then we are specifying this one F factor is colon. So it is C is the C not C. It is a left parenthesis EXPR and right parenthesis. So we are specifying this as a semantic action. So F is the left side non-terminal attribute value. F is the non-terminal attribute value. Okay, so here $$ equal to $2. Okay, so it is digit. So this is the last one, auxiliary function value.
Screen కనపడట్లేదు సార్.
Ma?
స్క్రీన్ గ్రీన్ గా కనపడుతుంది సార్.